In this third example, we're graphing a hyperbola given its equation in general form. So x squared minus 4y squared plus 40y equals negative 136. Let me move this to the other side. So I have what? X squared. That's perfect squared already. Like that, there's nothing to touch. Because look, there's no other x term right here, right? So that one's done. But we just have to work with this y this time. We got negative 4y squared plus 40y. Let me factor out the negative 4. So then I'm going to get negative 4 out in the parenthesis. Y squared minus 10y. Give a room a little bit. And on the other side, let me put that 136. Okay, so let us complete the square for this greens, the y squared and minus 10y. Let's think about it. What should we add inside this trinomial? What's half of negative 10? So to figure that out, you're going to take half of negative 10 and square it. Half of negative 10 is negative 5. And when you square negative 5, you get 25. So that's why I'm going to be adding 25 inside that parenthesis. But hold on a second. It's adding 25 inside this parenthesis. But what is it to the entire left-hand side? Watch. When you distribute that out, you are actually looking at negative 4 times positive 25. So inside the parenthesis, it looked like we were adding 25, but in fact, to the entire left-hand side, we are subtracting negative 100. So that is what you're going to have to do to the right-hand side. Don't be adding 25. Distribute that negative 4 and get the number negative 100. That is what we are going to add to the right side. So the right-hand side became 136 minus 100. Okay? All right. So this x squared is completely fine. It's just waiting. But my y's over here. Negative 4. But let us factor that into y minus 5 squared, right? Equals, when you do 136 minus 100, that gives us perfect 36. Okay? One step away. Let's divide everything by 36 because you want to have 1 on the right-hand side to make it into a hyperbola equation. So here's the equation. X squared over 36. That's looking good. But do simplify that second one. 4 over 36, which can turn into 1 over 9, right? So the second fraction turns into y minus 5 squared over 9. And all that equals positive 1. Now, this is a standard form of a hyperbola. So let us identify the center first. Is there anything being subtracted from x? Nope. So the x-coordinate of the center is 0. What's being subtracted from y? Well, we see negative 5 there, right? Y minus 5. So the y-coordinate of the center is positive 5. Okay? Plot that center first. So 0, 5, plot that center. Now, let's find the vertex. Should we go right, left, or up or down? Well, I don't know. Let's take a look. Now, you always go about the bigger amount to plot the vertex. What's bigger, 36 or 9? Well, 36 is definitely bigger, right? And notice 36 is a number under x. So that tells us to plot vertex or vertices. I'm going to do both of them. Go square root of 36, which is 6 to the right or left, or I'll say and because I want to do both of them, and left from the center. So watch, from the center, let me go right, 6. Ta-da, here's the first vertex. From the center, let me go left 6. Ta-da, here's my second vertex. Now, what do? We need to find the point that is on the asymptote, right? Now, we look at that number under the other number that we never used. So, this tells us that we go up or down. How many units? square root of 9, which is 3, from the vertices to plot asymptotes. So I'll do that. I'm going to go up 3 from the blue dot, ta-da, go down 3 from the blue dot, ta-da, and 2 more on these sides. So after that, draw some asymptotes. Okay, so asymptote that's connecting the center to the right side and going that way. So here's the first asymptote, and here's the other asymptote. And after that, we're going to sketch the hyperbola, and this time this is going horizontal. Start at the vertex, try to follow that asymptote, and go try to follow that other asymptote. There you go. And we're going to do the other one. Go up and go down. I don't think I ever showed you how you can check this using a graphing calculator. So let me do that for you right here, okay? So I'm going to just open up a, let me see, so many browsers open right here. Let me open up Desmo's scientific or graphing calculator, okay? So you guys can graph a hyperbola and check it using your graphing calculator. I'm going to type in the equation, which is x squared minus 4y squared plus 40y minus 136 equals 0. Okay, now they don't have the centers and everything plotted, but let me try to plot these important points that we found. We know the center should be at 0, 5. Does it look about right? Yep, to me that looks pretty good. Now, the other point, the vertex should be at, what did we say? We went 5 to the right from that point, right? So the other point, you know what? I can go click on it. Look, I click. They said we got a vertex at 6, 5. We do. And we have another vertex at negative 6, 5. And we do. Now, if you want to write or sketch the asymptote, we need to remember how to do the equation of a straight line. I think we will get to the equation of asymptotes in the later, yep, actually that's the next topic. So for this one, we looked at, so far we looked at 3 examples of graphing a hyperbola, with each becoming a little more difficult. Like this one started with the general form, but after hopefully watching 3 videos on graphing hyperbola, that you remember that number 1, plot the center, number 2, find the vertex, and number 3, plot a point that will be on the asymptote so that you can sketch different hyperbolas, okay?